Welcome to the Cal Corporation's series of videos about software engineering. The topic of this video is basic STL iterators. Before proceeding, make sure that you have already watched these other videos first. STL contains many collection classes and many algorithms. They often can all work with each other interchangeably, because they interact using a common iterator interface. These iterators have been designed to resemble the way a C pointer works for the iteration over a C array. An iterator is an object that represents a position within some collection class. The increment and decrement operators step to adjacent positions. Pre-incrementing has better performance than post-incrementing. Note that iterators for standard input and output streams don't support backward iteration. More than one iterator can refer to positions within a collection class. The equality operators test if two iterators represent the same position, and assignment causes them to refer to the same position. Even when standard input streaming iterators are equal because they represent the same position, their usage generally reads different values. Likewise, standard output streaming iterators don't overwrite each other. Dereferencing operators access the item located at the position being represented by an iterator object. Because these operations will need to be implemented in different ways for different kinds of collection classes, each collection class supplies its own corresponding iterator class. That iterator class's type is available because it is a nested class. The iterator object is available through the same begin and end function calls for all collection classes. The begin position is inclusive, meaning there actually is a dereferenceable item at that position. The end position is exclusive, meaning it represents a null iterator value that's one position after the final item's position. The iterator returned by a call to begin or end can be assigned to either an iterator object or to a const iterator object. Iteration by const iterator would be the same, except that dereferencing produces a constant reference that cannot modify that item. You would be forced to use constant iteration if the collection object itself had been defined as a constant variable. There exist cBegin and cEnd functions that are the same as begin and end, except that the return values from cBegin and cEnd are restricted, so that they can only be assigned to a const iterator. They don't serve much of a purpose other than for defensive programming. Like any return value in C, the value returned by begin is a compiler temporary until you assign it into some variable. And you will usually need to do so because you cannot use the increment operator on a compiler temporary. Those collection classes with random access provide a random access iterator. A random access iterator can do pointer math, which the more general bidirectional iterators cannot do. Any general iterator can test for the end of iteration using not equals, but having random access also provides testing by less than. Any general iterator can use an advance function or a next function to increment or decrement multiple times in one call. Advance changes the iterator that you give it. Next returns the new position without changing the iterator that you give it. Having random access also provides compound assignment operators. Any general iterator can call distance to measure the number of increments that would be needed to get from A to B. But having random access also provides the more efficient pointer subtraction operator. There is a convenience function for swapping two iterators. Begin is a member function of a collection class. There also exists an equivalent global function, also called begin, which might be more convenient for template programming. C++14 adds similar template programming alternatives for some other iterator access functions, like cbegin.